everybody, and welcome to another episode of Science Abounds, Science at Home, where we will discover home lab magic. In today's episode, we're going to look at the thionin-iron complex light-induced redox reaction. The thionin-iron complex redox reaction is strongly affected by light because thionin is a photoredox dye. Light can drive electron transfer that is slow or impossible in the dark. Thionin is a phenothiazinium dye, which is redox active, photoactive, and can exist in both the oxidized and reduced forms. Oxidized thionin is blue-violet in color, while the reduced thionin is colorless. Upon irradiation with visible light, thionin undergoes electronic excitation from its ground state to an excited single state, which may subsequently intersystem cross to a longer-lived triplet excited state. This photoexcited form of thionin possesses a substantially altered redox potential compared to the ground state, making it much more stronger oxidizing agent. In the presence of ferrous iron, the excited thionin molecule accepts an electron from iron 2 through a photo-induced electron transfer process. As a result, iron 2 is oxidized to iron 3, while thionin is reduced to a neutral radical species called leucothionein intermediate. This electron transfer step is thermodynamically unfavorable in the dark, but becomes energetically due to the addition of energy provided by photoexcitation. Following electron transfer, the reduced thionin radically stabilized through protonation by the surrounding solvent, yielding leucothionein. The formation of leucothionein is accompanied by pronounced decrease in visible absorption, leading to bleaching of the characteristic blue-violet color of thionin. So let's now go ahead and demonstrate this reaction. Okay, so I got my chemicals lined up. I got the thionin dye that I pre-made. I just added 100 ml of water to the powder, and that's now nicely dissolved. I've got iron chloride, iron sulfate, and sulfuric acid also. So what I'm going to do in a 500 ml beaker, I'm going to add 10 ml of the thionin solution. Okay, I'm just going to pour that in. Okay, so 10 mils. It doesn't have to be accurate. And I'm going to put that into the beaker, like so. Put that aside. And then I'm going to add 10 ml of 3 molar sulfuric acid. Okay, so need my measuring cylinder again. And then I'm going to add 10 ml of 3 molar sulfuric acid. Okay. I'm going to put that into the beaker. Okay. And then I'm going to add water to take it up to 500 mils. Add some more water. Okay, we're at 500. And what I need to do is I want to add 2 grams of iron sulfate. So I'm going to weigh out 2 grams of iron sulfate. And then, there we go, 2 grams. But before I add the iron to the solution, I'm going to make the room a little dark. So what I'm going to do now is I'm going to add the iron, and then we're going to put it into, I'm going to add I want this totally dissolved. So I'm going to turn off the lights. Again, I'm going to turn off all of the lights, and then I'm going to put a direct light source to the beaker. So I took the beaker outside into direct sunlight, and as you can see, the solution's gone colorless, and this is due to the formation of the leukothionein. Well, I hope you enjoyed that demonstration of a light-induced redox reaction. And this reaction is a model system for photo-induced electron transfer. It's also studied in excited state kinetics. It is used to understand redox cycling between iron 2 and iron 3. Used widely in physical chemistry to explore how light drives chemical reactions. It also mimics aspects of natural photosynthetic electron transfer, and it also helps design light-driven catalytic systems. And also, these light-induced redox reactions are used in studying solar to chemical energy conversion mechanisms. If you like the video, please hit the subscribe button, also the like and share button. It helps support my channel. Thank you to all my subscribers who have subscribed. It means a lot to me. If you want to send me a comment, please leave me a comment. I'd love to hear from you. Also, if you want a copy of my video notes supporting this experiment, please send me an email specifically requesting the notes for this episode, and I'll be happy to email them to you for free. Please also send me email of your photos and videos of you doing your own home lab experiments. I would love to build a home lab community. Until next time, keep on experimenting. Goodbye, everybody.